Welcome. We're now looking at trig functions not on the unit circle. So let's take this point, 5, -2. I'm going to make a little place showing where it is. 5, let's say it's out here, and -2 is there. We're at this point. What we have is an angle, a right angle. And the distance here is 5, and the distance here is 2. It's actually because we're going down to -2. The distance is actually 2. So we'll keep it negative because that's the y value, and the x value is 5. So now remember, for the trig functions, we need certain things. For the sine, it can be shown as either the opposite over the hypotenuse. So we have so, and then ka for the cosine. So that's the adjacent over the hypotenuse. And then toa, the tangent, is the opposite over the adjacent. And the other three are the reciprocals of those. Now back to here, though, we also know that what we call for this angle here, and that's our angle because the angle's coming from 0, 0. This is the angle that we want. Let's now increase that. We know that the opposite is the y value. The adjacent is the x value. So another way to state sine is, and over here, this is the radius out from the center to wherever this circle would be. Let's pretend to have a circle there. In fact, I'll make a circle, not a good circle, but close enough. The unit circle is here, where it's all ones. But we're much out farther than that. This is 1. We're going out to 5 here. So we're no longer on the unit circle. But the x and y still fly. The sine, the opposite, is actually the y value, and the hypotenuse is the radius. The cosine is the x value, and the hypotenuse is the radius. And the tangent, the opposite, is the y value, and the adjacent is the x value. So opposite and over hypotenuse is the same as y over r, and so on for all three of these. So these help you determine what numbers to use to get the sine, cosine, and tangent. So now let's actually do that here. I'm going to take this triangle, make it a little bit bigger so we can work with it. Here's our angle. We know this is 5. This is 2. Actually, -2 we'll use for opposite and angle. And we need the r. We don't know what the r is, but we can use a squared plus b squared equals c squared because we have a right triangle. And a would be the x value, b would be the y value, and c would be the radius. So what we have is 5 squared plus -2 squared equals r squared. 25 plus 4, 29. 29 equals r squared. R is equal to plus or minus square root of 29. Can't be negative. A distance can't be negative. So therefore, the radius is always positive. And we now know it's the square root of 29. For the sine, y over r, here's y, and here's r, and here's x when we need it. So y over r would give us 2 over root 29. Yay, oh, but it's a -2 for this purpose. However, we're not allowed to leave a square root on the bottom of a fraction. So you are required to multiply by the same square root of 29 underneath it. So what we get now equals -2 root 29 over 29. For the reciprocal of that, take this one before you have to rationalize it, because when you do the reciprocal of it, that means we don't have to change it back from having rationalized it. We can just do negative square root of 29 over 2, with the cosecant being nothing more than the reciprocal of the sine. Now for cosine, let's figure this same thing out. We need the x over the r. The x value is 5 and the r value is square root of 29, but we have to multiply by the square root of 29. If we multiply them top and bottom, we're only multiplying by 1, but it gives us what we want, which is 5 root 29 over 29, because this way there is no square root radical sign in the denominator. And we'll use this one, reciprocal of it, to give us the secant, square root of 29 over 5, because it's perfectly fine to have a square root in a numerator, just not in the denominator. Now over here for the tangent, this one becomes a good deal easier. It's just simply the y value over the x value, but it's negative because the y value is negative. So negative 2/5, and the cotangent's the reciprocal. These become a little easier with no rationalizing needed. For these two, it's okay to make them decimals because they are ending decimals. So negative 0.4 or negative 2.5 would be acceptable answers. You do not do that with these others because for this one, this one, this one, and this one, we would get decimals that never terminate and never repeat. So you can't make them a true, well, they're irrational numbers and we need rational numbers. Or let's see, let's calculate it. Yes, we don't want to use decimals that never end. In other words, no, and in fact, I need to change here. These was not approximations, these were equals. So we want exact answers, meaning equals, no approximations. All of these are exact answers set up the way they are. Now let's do another one. First, let's think about what happened here. Determining the radius by using this, and then using y over r, x over r, and y over x, or opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, using that. Let's do this with the next one. So it's negative 7, negative 3. That tells us that this is our x value and this is our y value. So down here, well, that means what we need is the r. So if we want the sign, we want to do the y value over the r. Well, we know the y value, but we don't know the r. So r squared equals x squared plus y squared. R squared equals negative 7 squared plus negative 3 squared. R squared equals 49 plus 9. R squared equals 58. R equals plus or minus square root of 58. But we can't do that negative. So now we need to think, can this be broken up with a perfect square in it? Over here, I'm going to say 58. Well, let's take that 58 and put it into two numbers. And it's actually 2 times 29. But there's no perfect square for either of those. 29 can't be broken down. So that means we have to leave it just as it is. But now that tells us that for the y value, this is going to be, let's see, it was negative 3. This is negative 3 over root 58. But we have to rationalize it. So we multiply by square root of 58 over square root of 58. I think I can write those a little neater, so I will very quickly do that here. Square root of 58 times square root of 58 over square root of 58. So my actual answer for this one is negative 3 root 58 over 58. This one I'll use for the reciprocal, never to get a negative square root of 58 over 3. For the cosine, that one's x over r, and that means it's negative 7 over square root of 58. And when I multiply top and bottom for that one, I get negative 7 square root of 58 over 58. Okay, that's better. And we'll use the reciprocal with that one, negative square root of 58 over 7, because the secant is the reciprocal of the cosine. And for the tangent, that's the y value over the r value. And the y is -3. Oh, not r over x. Y over x is -3 over -7, which is 3 over 7. And the cotangent would be 7 over 3. Both of those positive because the negatives cancel out. Okay, see, I got those -7. Just double check it for myself. -7 was the x and -3 for the y. And so these are the 6 answers for this one. Let's get those numbers back. Okay. We have good numbers here. Cannot make these two a decimal because it would give us never-ending decimals. And therefore, this is the most exact answer. Now, here's something slightly different, although we're going to use part of the same skills. The tangent for an angle is 3 over 8, and the cosine of the angle is less than 0, meaning it's negative. But the cosine's negative. Find the trig functions, the 6 trig functions. Well, we already know the tangent, so let's write that in. If we know the tangent, we know the cotangent. Okay to do 1 2/3, but might as well leave it as 8/3 there. So those become much easier to work with because it's given. All right, now, when you have the tangent, that means that this is the y and this is the x. So we now know that x equals 8 and that y equals 3. They're both positive here. Okay, wait a minute. It tells us the cosine's negative. If the cosine's negative, that means that when I take these two out, the 8 has to be a negative. So x actually is equal to -8. But in order for 3 over 8 to be positive for the tangent, then the y has to also be a negative. So in order to get 3 over 8, we have to have -3 over and -8 because we're told that cosine is negative. That's an important consideration here. Okay, very important to recognize. A little star by that, because then that leads to those being different. Now, in order to do the other 4 sine, or sine, cosine, cosecant, and secant, we need to know what the r is, because the sine is y over r, the cosine is x over r, and then these are the reciprocals, r over y and r over x. So that means we didn't know what r is. So -3 squared, x squared. Oh, that's y squared. Well, we'll put 8. We'll put 8 squared here. -8 squared. So it's x squared plus y squared equals r squared. 64 plus 9 is r squared. 73 is r squared. R is equal to plus or minus the square root of 73. That one, 73, is another one that cannot be broken down. There are no perfect squares in it. So let's bring that over now and start using it. Oh, and we can't have negative for the r. Only the x or y can be negative. So if we're doing y over r, y is -3 and square root of 73. Oh, we have to rationalize it. Multiply top and bottom by that square root of 73. And on the bottom, we just get the 73. This one then is also a reciprocal down here. The r is square root of 73. And we have a 3 and we have a negative in front of that whole thing. I'm going to rewrite that to make sure I get that negative in. Negative square root of 73 over 3. So that's the y value, and its reciprocal, the cosecant. That's the sine value, and then the reciprocal cosecant. Now for the x, we'll do the same type of thing, except now it's a -8 square root of 73, which of course then is still negative, and it's 8 times the 73 on top, and leave the 73 on the bottom. And then this one, the reciprocal of that will be what we need for secant. Negative square root of 73 over 8. Ooh, they're good at staying. we have all 6 of those trig functions based on this information. And let's do it now with a different one. In this one, it's not the tangent. What we have is the cosecant. So we have to come here, and first I'm just going to write it in for the cosecant because we know that's square root of 13 over 2. Cosecant is the reciprocal of the sine. So we know that's negative 2 or negative 2 over root 13, but we have to rationalize it. Negative 2 root 13 over 13. So those two are easy, but now we need the others. And to get the others, that's where we determine that if it's the cosecant, well, first I know the sine is y over r, so the cosecant then is r over y. That means that this is r and this is y. All right, we know y and r. I want to know what x is. X squared plus y squared equals r squared, because that's a squared plus b squared equals c squared. A squared plus b squared equals c squared. Definitely another good use of the Pythagorean theorem. I don't know what x is, but I do know what y is, and I do know what r is. Now, because this is negative here, that's probably a negative 2, but it won't matter because I'm squaring it. Subtract 4 from each side, and then take the square root of each side, and it's plus or minus 3. Now here, it tells us here cosine is greater than 0. Cosine is the x. Because it's greater than 0, that means it's positive, and so we'll throw out that negative one and only use the positive 3. And now we know we know that's x over r, so we know it's 3 over root 13. And then that's 3 times root 13 over 13, because we had to get the square root out of the denominator. And now let's do these. Immediately I can take the reciprocal of it and bring that to secant, square root of 13 over 3. And last now for tangent. For the tangent, we need the opposite over adjacent, which is the same as the y over the x. We know the y value is a negative 2, and the x value is a 3. Negative 2 over 3. And the reciprocal is the cotangent, so it's the negative 3 over 2. We don't change the sign, we just do the reciprocal of the numbers. There, now that's shown how to do this when we have, well, different things. Tangent was one of them, cotangent's another. We figure out or remember what is r, what is x, what is y. And with those three, we can find all of them. Now, this next part is a reference angle issue. We have to talk about what it means to have a reference angle. First, the general reference angle you first learned is up to 180 degrees, or from 0 degrees. If I have an angle such as here, and let's call that 140 degrees, is that right? Yeah, okay, one close enough. For this angle, well, actually, that's the thing. That whole angle is 140 degrees. But the angle that is just here from 180 to there, that's called the reference angle. Oh, I changed that to that. Let's fix that. That was supposed to be 240 because I'm trying to show the one that's larger than 180. So let's see. Actually, this is 270. 240 would be much closer. Let's call this 230. So this is a 230-degree angle. Question is, what's the difference here between the 230 and the 180? So 230 take away 180 is 50 degrees. And that means this part here, 50 degrees, is just this. From 180 to 230 is a 50-degree angle. 230. So that's a 50-degree angle. I'm going to come up here and I'm going to put the 50 in. See if I can write that. 50 degrees. Okay. Now, that's the angle thing, because what it really is 180 plus 50 gives us this 230. Right, so I'll write 230 here. So it's easy to see that that was what I was trying to get to. But from just 180 to 230 is 50. That's the reference angle in degrees. We want it in radians. So now what we determine, we have 4.1 radians, and 4.1 radians means we go past 3.14, which is pi here at 180, and go up to where about 4.1 might be. So I'm going to guess that's about 4.1. Give or take, maybe about there. Well, now, if that's 4.1 and this is 3.14, so what we want is this distance here. We want from 3.14 to 4.1. 3.14 to 4.1, that would be the reference angle going from the 180 area to where about 4.1 is. To do that, we just simply subtract 4.1 minus 3.14 is 0.96. So the difference between 3.14 and then say 4.1 or 4.10 gives you 0.96 radians. 0.96 radians. And that's what this distance is right here. So this is 0.96 radians from 3.14 to 4.1. There's another one underneath it. Here's 0, go all the way around. Here's 360. It's the same thing. But now 360 is also 2 pi. Pi is 3.14, which makes this 6.28. So one time around here is 6.28 radians. Well, where we're supposed to do is 6 radians. So if that's 6.28, then 6 is pretty close to it here, because here's 3.14. So let's call this 6.0 radians. I don't want this angle here. What I want for the radians is the reference angle for radians is essentially the distance on the circumference. So we want to know that difference. If this is at 6.28 and this is 6.00, we do 6.28 subtract 6.00. Oh, 0.28. 0.28 radians. Because 6 is very close to 6.28. Okay, sooner or later, I'm going to get this. I'm going to win this battle. All right, I won that battle. So that's how you find the radian reference angle. Radian reference angle, important part to think about. Okay. Quadrantal angles. All right, think about for this, when you're at 90 degrees, you have a 0 and 1 point, which means here, because their radius is only 1, we just divide by 1 every time. So the sine is the y value. The cosine is the x value. The tangent is y over x. That means it's 1 over 0, but you can't divide by 0. So you put undefined. 1 and 0 and undefined. Now for the reciprocal of tangent, we can switch these and do 0 over 1. So it's perfectly welcome then to say that it's 0 for it. Since sine is 1 over 1, the reciprocal is 1 over 1, so cosecant is 1 also. Here, the cosine was 1 over 0. So we need to do, well, let's see, 0. Oh no, I'm changing that. This is 0 over 1. Yeah, every number has a 1 underneath it. So if that's a legitimate 0, we put a 1 into it. But then the reciprocal of it would become 1 over 0. And we're not allowed to do a 0 on the bottom. We have to write undefined. Okay, so here are our answers so far for this. Now let's look at 180 degrees. And so on the unit circle at 180 degrees, the x is -1 and the y is 0. So the sine, since that's y and that's x, the sine is 0, the cosine is -1. The tangent's y over x, which is 0 over -1, which is a perfectly fine 0. 0 divided by anything, as long as it's not 0, is 0. So since that's 0 over 1, the reciprocal would be 1 over 0, which we're not allowed to do. So you put undefined, or abbreviation of it. Since -1 has a 1 under it, we can do the reciprocal, and that's still -1. Here, we can take that fraction and use the reciprocal, so it's -1 over 0, but we're not allowed to divide by 0. So this one is also undefined. 0, -1, 0, -1. Here are two undefined. For all of the quadrantal angles, you have two of them that are undefined. For 270, that's at 0 and -1. So we have a -1 and a 0. This one would be 0. Oh, let's see. No, that one's 0 over 1. So that means this one is undefined. And here we have -1 again. So for the tangent, if cosine is 0, it's on the bottom, which means this is undefined. And then for the reciprocal, that's 0 over -1, which is a perfectly fine 0. The last one of the quadrantal angles, named because they're the quarter points essentially throughout the entire thing, is when we're out here now, we're at 1 for the x and 0 for the y. 1 and 0, we know that's 1. We're doing 0 over 1 for x, y over x, so that means for the tangent it's 0. But then these two are undefined because when you do the reciprocals, you end up with the zeros on the bottom being divided by, dividing into it. So we can't divide by 0, so that means two of them are undefined like this. There, that covers a number of topics from this section about using any angle for trig functions, in particular when they're not on the unit circle like started with here. So hopefully these are good examples to understand how to do them. Thank you for watching and listening.